Where's your picnic, Anna? Nice. That's fine. What food is going to be at this said picnic? Anything good?
Everybody's bringing food. I'm bringing cupcakes.
Nice. Chocolate, vanilla, mixed?
Chocolate.
What kind of frosting?
Blue.
I'm just a vanilla frosting guy.
It's going to be vanilla frosting with dark blue.
It's all right. I'm not a chocolate, though. Gotta go. I'm just plain old vanilla. Maybe some sprinkles on top if I get nuts. You know? Just like ice cream, it's just vanilla ice cream with a couple colored sprinkles. I'm good. I don't get nuts. Basic.
No, like chocolate syrup or anything?
Nope. No whipped cream, none of that. Just basic.
Cream?
Basic.
Cream is literally vanilla.
No. Basic. I'm good. All right. Anybody else? Sorry, big weekend plans. I just didn't want to dominate with Anna here. No, Spence, just hanging out, balled up in the corner of your room until Monday when it's time to come out and go to school. I used to do that too. It's fine. All right. Quick review for me. 2 methods of proving triangles congruent from yesterday. 5.
The third angles theorem. Wait.
We're in trouble.
Wait.
We're in trouble.
Those ones right there. Okay. SSS.
The two from yesterday.
SAS.
Side, and side angles theorem. Oh boy. For writing down two triangles. Two triangles are congruent by the third angles theorem. Oh boy. Yep. 2 more today. The third one. ASA, which I'm sure you know the abbreviation for now from yesterday. Angle, side, angle. Angle, side, angle. And, hey, where's the side in angle, side, angle? Where did I put the S? In the between. So if you want to use this fact to prove 2 triangles congruent, that side has to be in between your 2 angles. Okay, the side needs to be in between the 2 angles. If it's not, it's okay. Okay, it's okay if the side's not, because I have a 4th one today which says, all right, if the side is not in between the angles, they are still congruent, but you have to use this method, AAS, which stands for angle, side. All right, I got a 5th and final one coming up next week, but here are your 4 for now. With today's methods, here's what I'm basically telling you. Hey, if you have 2 angles and a side, guess what? They're congruent. You just got to figure out what method it's going to be. So if you have 2 angles and a side, they're going to be congruent. You just got to figure out if the side's in between or not. Issues? All right, let's just hop right into a proof. Here's the deal today. I'm going to do 2 proofs with you, and then I'm going to give you probably the hardest one we've done to date to see if you and your groups can do it or not. All right. And oh yeah, my softness wore off pretty quickly. I didn't write any of the givens or mark the diagram for you. Suck it up. QS bisects angle PQR. PSQ congruent to RSQ. All right, let's mark your diagram. PSQ, RSQ. Like I started every proof off this unit. How many pairs of corresponding parts did I give you? How many pairs of congruent corresponding parts are given? 1 out of 3 I need, right? So that means you guys are going to help me with finding 2 of them. 2 more. All right? And these colored pencils are to be used in the next proof. All right, so find another pair for me. Where on this diagram is another pair of corresponding congruent parts? 13.
SQ is equal to SQ.
Everyone, I may laugh all the time, Charlie, but somebody's got to say it. It's got to get written down, right? So might as well be the first one. Reflexive. So I got an angle, I got a side. I need one more pair of congruent parts for me. Please, one more pair of congruent parts. I'm almost there. 3, use your givens. Use your givens.
Is it PQS is equal to RQS?
Correct. Angle PQS congruent to angle RQS. How do you know that, Spence? What do you see in the givens?
So that QS bisects.
Good definition of bisects. There's another angle. Now what we need to figure out is it angle side angle or angle side? Again, just like I did yesterday, cover up one of the triangles and figure out if that side, that reflexive side, is in between the two angles or not. Okay, so you guys go ahead and see if you can determine the method. Is that side in between or not? And all you need to do for the congruent statement, just copy it. You don't have to worry about what angles or sides match up like yesterday. Triangle PQS congruent to triangle RQS. And what you figure out, what method should it be out of the two? 5?
Angle side angle.
Angle side angle, good, because that side is in between. Good work, everyone. Questions on this one, because I want to get a little tougher now. A little tougher. All right, let's get a little tougher. Go ahead, do your thing, set everything up. All right, here's why I've provided colored pencils. Take a look at the two triangles I'm asking you to prove congruent. Do you notice that they overlap each other? And I think when two triangles overlap, I think it's easier to see them when they're colored in individually. So if you want, it's not needed, but I think it's going to help you. Take a colored pencil, highlight triangle ACD, and take a second colored pencil and highlight ECB. Again, I only use these colored pencils when everything overlaps. If they don't overlap, they're not really needed. And hopefully, this allows everybody to see all the angles and sides in each triangle. Okay, this clearly shows you what the angles and the sides are in each of the triangles. All right, let's go to the givens. Angle DAC. Everyone look at DAC. Is that a full angle in one of my triangles? A full one? Yes? No? Yes? And that's congruent to BEC. Is that a full angle in one of my triangles? Yeah, I ask you that because I can put an A here now. I gave you a pair of corresponding angles. Let's go to the next given. BC. Ready, everyone? DC. Everyone look at DC. Is DC a full side of a triangle? Yeah, and for mine, it's my yellow one. Congruent to BC. Is BC a full side of one of the triangles? Yeah, so guess what? You're off to a good start. I gave you two pairs of congruent corresponding parts. And here's why this proof might be tough. Where's the third pair? That's what I want you and your group to look at. Where's the third pair? Right? Where's the third pair in the diagram? Because can't really go back to the givens. We used all the givens, right? The givens are already angle. I already have an angle and a side from the given. So this is probably something you got to find on your own by looking at the diagram, because the givens aren't going to help you anymore. So where is that third pair? Because I can't say the triangles are congruent yet. And I know some of you might be hesitant to say it because we haven't used this reason for this statement in this unit yet. I know this happened in my 8th period class yesterday. I asked the same question, and the first hand that went up said, oh, hey, the vertical angles are congruent. True, but why can I not use that? You could write it down, and I'm never going to mark it wrong because it's true. But what's the problem? Are these vertical angles angles in these two triangles? No, so you can't put an A next to it. You could write it down, it's 100% correct, but it's not going to help you prove the triangle's congruent. Does anybody see another pair of angles or sides, though, that are actually in those two triangles that are congruent? What do you guys got? Everyone look, yeah, angle C. Take a look at angle C. Everybody see angle C? That is an angle in both triangles. And I know we've never used it this way, but yes, angles can be reflexive too, just not sides. All right, angles can be reflexive too. So that was one tough thing about this proof. Here's the second tough part. Is this an angle side angle or an angle angle side proof? Because this is tough when they overlap, right? It's tough. Here's a suggestion, and I hope you take it. Instead of trying to guess by looking at the diagram, take one of the triangles, ready? Take one of the triangles and draw it out separately. So watch, I'm going to take triangle ADC and draw it out here separately. And I'm going to put all the markings I put on triangle ADC on this one. So does everybody see I put an arc mark at angle A? I put a hash mark on DC. Bless you. And I put an arc mark on angle C. Makes this real easy now, doesn't it? Is that side in between? Is DC in between the two angles or no? Yeah. 9? Yeah. It is? Here, okay, here are my two angles. Here's the side. That side's in between. You know what I mean by in between? So you're saying this side is in between these two angles. Maybe I'm not. That's in between. Yes, no, we sure, Elio? We sure? What in between means? Okay, then why are we saying that one's in between? Is this side right here, this hash mark in between the two angles or no? No. So what method should I be using? One more time. Angle, angle, side. Draw out one of the triangles if you're having issues. Because some of you may have looked at just the diagram and said angle, side angle, but you're using a side from a different triangle and an angle from a different triangle. Okay, yes, Spence.
Are you sure you drew that?
Say that again.
You sure you drew that congruent line mark in the right spot?
Where should it be?
On the triangle, it looks like the full side is AC.
No, remember, look at the given. DC was congruent to BC. Nothing mentioned AC. That's why I suggest drawing the triangle out. Okay? Any other questions? Okay, look, I really don't want to see people struggle on their own. So if you want to go somewhere right now and work with somebody that's in a different group, that's fine. All right, but I need some collaboration on this last proof because I can't see somebody just struggling on their own. Okay, so if you want to work with somebody else, go to a different table or whatever and move, but I need to see some collaboration on the proof I'm about to give you. It's not in your packet, so you're going to have to draw it, and you're going to draw it on the very back. So close your packet up, everybody, and flip it over. Here you go. This might be the tough. This is going to be the longest one to date, no doubt. All right, it might be the toughest one. We got to talk to each other here. There it is. If you think you have it, let me know. When you think you, or if you're just plain stuck and you don't know where to go, let me know. You will not use anything new. Nothing new here, guys. Nothing new. You might have a reason or two we haven't used in a couple weeks, but nothing new.
So take what are you trying to do right now? What are you trying to do?
Start off by saying, hey, in those givens, did I provide any corresponding congruent parts? Let's go. Let me know if you think you got something. Yes, this is tough.
Yeah, so we can subtract. Yeah, equations are you gotta do. You gotta do KRO minus minus MRF. So yeah, so it is. So we're gonna do it to both
And
sides.
our is reflexive.
Oh, yeah.
Okay. Trying to do triangle camera is going to triangle camera. Angle camera is equal to
Yeah. First, you gotta prove that KRM. First, you gotta prove that KRM is equal to.
Use your givens. Don't start making up stuff. Use your givens to get more angles and sides.
Oh, okay, I can see that. So,
Yes, this is me challenging you in an upper level class here.
no, it's that's just
No, don't start adding, subtracting triangles. Don't start doing that. You can only do sides and angles replacement. Okay. Why? Triangles. So just don't start doing triangles reflexive. Only angles and sides can be reflexive. Okay. Again, why did I give you those givens? To hopefully lead you guys to sides and angles that are congruent. 3 and 6 being congruent should lead to another pair being congruent.